When we're changing the order of integration, that might require us to invert functions. We might have to pseudo-invert functions. That is, invert a function what isn't actually invertible, like x equals y squared or y equals x squared. It's not that we can't write one nice inverse function, but we do write two inverse functions. We can split it up into two inverse functions. Then as long as we're aware that this is the case, we can deal with that. So if we have a region that has the top and the bottom half of an x equals y squared parabola, we just have to describe the top half with y equals positive square root of x and the bottom half with y equals negative square root of x. So we have to be conscious of how we invert our functions, especially when they aren't invertible. Now, in the case of parabolas, another thing that we should be aware of, our standard form of a parabola where we write y equals ax squared plus bx plus c. This is very inconvenient to invert. It's inconvenient to solve for x in this form. The x appears twice. It's just kind of a mess. So it's more convenient for us to rewrite our standard form into a vertex form. The vertex form has only one instance of x, and here we can perform inverse operations in reverse order. So this is more convenient for us as far as inverting. So if we wanted to invert from the vertex form, we just need to solve for x. So subtract k from both sides. Divide by a. And here's where we undo the radical, or sorry, undo the square with the square root. So now we can see what our plus or minus is going to be. And so now we have x is equal to h plus or minus the square root of y minus k over a. The way we want to make sure that we understand what this expression is telling us. This is putting h in the middle, and then there's plus or minus the square root. This is how the symmetry in this parabola shows up in the equation. This is where we see the symmetry in the equation. H is in the middle, and then we either plus minus the same amount. So here is where we see symmetry. H is in the middle. And then the plus or minus the same amount, that's the symmetry, in this case, on the left and the right. So that plus or minus is giving us that left and right symmetry. Here's h in the middle. And then there's plus and right, left and right symmetry. In the case of the sideways parabola. I guess there's K in the middle, and there's plus and minus up, down symmetry. This is one of the things that we're going to have to think about when we're thinking about inverting functions. What isn't invertible? We can write an expression, then we have to be aware of which parts, which inverse function we want. Standard form in parabolas, standard form is bad for inverting. Vertex form is better for inverting. Questions? In the instances where I'm talking about the quadratic formula being bad, it's really just the way that we write the quadratic formula hides this middle and left-right symmetry. So if you think about wanting to solve ax squared plus bx plus c equals 0, we know that the solution is given by the quadratic formula, the opposite of b. I'll start to write it like I prefer to write it, where we write down the symmetry. But normally when we write this, we write x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. This is all nice and simplified, which is why we like this in algebra class. But then when we start wanting to graph things, this hides the symmetry that's there. It still has the symmetry that's there. There's that middle, negative b over 2a, plus or minus the square root of b squared minus 4ac all over 2a. There's that middle and then the plus or minus part. But just by writing it this way, kind of masks that. This hides the symmetry. And I think it would be healthier if we emphasize the symmetry by separating off negative b over 2a plus or minus where we can see that negative b over 2a, that's the middle. And there's the plus or minus the same amount, that's the symmetry. So this, I think, does a better job of emphasizing the middle. And then the plus or minus gives us the left-right symmetry. One of the reasons I thought of this is that we used to teach algebra. We don't anymore, but we used to teach algebra. And I used to allow students to bring in notes for their test. And then I had them turn in the notes, not to grade the notes, just to see what people needed to write down. And some students were writing down the quadratic formula because they didn't have to memorize it. But then when I asked them, when they also had a separate note that said the vertex, the x coordinate of the vertex was negative b over 2a. Another note that said, a separate note that said the x coordinate of the vertex was negative b over 2a, not realizing that they had the same thing twice, because that was showing physically the disconnection between the quadratic formula and what the parabola is supposed to look like. Does that make sense? So that's when I started deciding to shit on the quadratic formula all the time, saying quadratic formula is trash. Now, this isn't a problem. This isn't a problem for those of you who are okay with remembering a lot of disparate facts. But if you find yourself forgetting small things here and there, start looking for how they are connected to things that you easily remember. Because overall, it's the connections that we make in the material. That's what demonstrates our understanding of the material, not remembering the slope formula. That was another one, by the way, when you have notes on a test. If you have to write down y2 minus y1 over x2 minus x1, you don't have a problem remembering formulas. You don't understand what the slope represents. You cannot simultaneously say, I have to write down y2 minus y1 over x2 minus x1 and claim to understand what the slope represents. If you understood what the slope represents, you wouldn't have to have the formula. The formula would just be getting in the way. Any questions? Incidentally, if you think those two things can exist, then the problem is even worse. You don't understand subtraction. I know it seems like a crazy thing to say. It's like, oh, you can't tell people they don't understand subtraction. I'm like, oh, guys, you probably don't really understand counting. I know y'all can count, but do you understand counting? That's the question. I'm not being insulting. We raised you to be this way, and you don't get to blame people for being the way that they were raised to be. We raised you to count base 10, and when you're like, oh, how does this shit work? You're like, oh, shut up and do it. And you're like, well, all right, because you were a kid. So we did that to you. So I'm not like blaming you for not knowing stuff. It is not okay to blame people for not knowing stuff. Like cursive. Cursive is a trash writing system. So all of you watching this video think we need to teach the kids cursive. We do not need to teach the kids cursive. We need to stop teaching the kids cursive. You need to update your skill set, Grandpa. Cursive is a trash writing system. People can't read it anymore. If people can't read what you're writing, your writing is trash. If people can't read what you're writing, then your writing is no good. If you are systematically taught a way to write stuff down that other people can't read, we need to stop teaching you how to write that way. Does that make sense? This is fucking critical because there are some people out there that think cursive should be back in schools. I'm like, oh, motherfucker, we fucking type things now. Number one, we type things now. Almost all of our communication is just typed or tapped. Are those going to be different things? Can we say typing when we're tapping? Typing versus tapping? I don't even know. It doesn't matter. Cursive is trash. Like, look at old letters. You can't read them because you weren't taught that writing system. Because you shouldn't be taught that writing system anymore. Why do I not use cursive? Because people can't read it. Why is my writing so bad that it's barely legible now? Because I was trained on cursive, and some of those habits have leaked in my habits when I write. Any questions? Also, if you didn't teach people cursive, what do you expect? They just born with it? They just know? Kids today can't change a tire. Number one, kids barely have to change tires anymore, Grandpa. It's only your old piece of shit car that you have to change the tire on. And second of all, did you teach your kids to change a tire? No? Then shut the fuck up. You know what I mean? If you're mad that your kids can't change a tire, teach them to change a tire. You know what I mean? Old people are annoying. I guess the summary is old people are annoying. We need practice writing double integrals because that's going to be an important skill later on. Probably shouldn't rail against person and have to like literally write down stuff. They're your notes. Think of this one. All right, we're going to practice some double integrals. These are the two regions that we care about. I also want you to find at the bottom, I want you to find the areas of these regions. You can find the area, you can evaluate your double integrals to see that they come up with the same area, number one. And then you can find these areas in some other fashion to make sure that you're getting the correct value for the area. Remember, the double integral of 1 dA will give you the area of the region. Let's take a look at what we needed to get. The exercise here was describing the region. And when I described the first region, the way I'm checking this, speaking of, if you're thinking about stuff that you're turning into me, the way I'm going to look at this, I look at this region as 0 to 2, 0 to parabola in both ends, or 0 to 4, 0 to parabola, because that's where my line is drawn. If I go left to right, or bottom to top, I go 0 to 4, left to right, 0 to parabola. Or if I go from left to right, 0 to 2, I go bottom to top, 0 to parabola. So that's why this one showed up 0 to parabola in both cases. On the other region, I just had the top version of that. If I go 0 to 2, 0 to 2, I go from the parabola up to 4. So that one is parabola to 4. And then the other direction, 0 to 4, parabola to 2. 0 to 4, parabola to 2. And then the region R1 is 16 over 3. R2 is 8 over 3. So we're just taking the region and dividing it into 1/3 and 2/3. What you would want to do is make sure that your 4 double integrals give you the correct area. But if I just ask you for the area, find the area by any means necessary. In particular, notice that in R1, I started with the dy dx integral. And this, after we did the first step, we landed at the integral we would set up back in Calc 1. So back in Calc 1, if I said find the area under 4 minus x squared from 0 to 2, this is the integral you would have set up. So the dy dx integral integrates right into the integral that you would have set up anyway. All right, that's going to do it for today. Please make sure the caps are on the pens. The pens are in the tray, and bring up your cards. Everybody have a good day, and thanks for playing.